Hello everyone and welcome back to our channel CNCTrain by MTAP Technology Center. We hope you are enjoying our pick and place video series. Now we are presenting the sixth video of this series. In this video, we'll delve deeper to learn about how to create a robot program using the offline method in ABB Robot Studio 6.05. Robot programming defines the workflow of a robot and it can be done through the online or offline method. The offline method involves programming the robot's movement, which means moving from current position to new position, while the path between those two positions is automatically calculated by the robot. If you want to learn the initial steps for creating the robot program using the offline method, this demo will help you. Now, we will move forward with this video and learn about the creation of robot programming in the offline method in detail.
Demo on creating a robot program using the offline method. Robot programming defines the workflow of a robot and it can be done through the online or offline method. Programming done without being connected to a robot or a real controller is called offline programming. The robot movements are programmed as pose-to-pose movements, that is, move from the current position to a new position. The path between these two positions is then automatically calculated by the robot. Programming done by connecting to a real controller is called online programming. Online programming also implies that the robot is used to create positions and motion. You will view the steps for creating a robot program in two parts. In this part of the demo, you will learn the initial steps that need to be performed while creating a robot program using the offline method. Note that before creating a program for your robot, you should set up the workstation, including robots, workpieces and fixtures, in which your robot will work. Click or press Next to continue. On the Home tab, in the Freehand group, click Jog Linear. A coordinate system will be displayed at the Tool Center Point (TCP) of the robot. The linear mode is used to move the robot. In this mode, you can click the axis from which you want to drag and move the TCP to the preferred position. Select the Controller tab. In the Controller Tools group, click the arrow next to Inputs, Outputs. The Virtual Flex Pendant window opens. The Virtual Flex Pendant, also called Teach Pendant, is a programming pendant connected to the virtual controller. Click the Control Mode selection. The Control Mode contains three operational modes for the controller: Auto, Manual, and Manual Full Speed. The robot can move with reduced speed only in the manual mode. It can move if the enabling device on the flex pendant is activated. Select the manual mode. The mode changes from auto to manual. Next, you will create a new routine for robot homing in the program. Routine is a set of data declarations followed by a set of instructions used to implement a task. Routines can be divided into three categories: procedures, functions, and trap. Click or press Next to continue. Click the menu drop-down arrow on the flex pendant. Select Program Editor. Click Routines. At the bottom left of the Flex Pendant window, click File. From the menu that appears, select New Routine. On the Routine Declaration page, double-click in the Name field. Enter the routine name as Homing and retain the routine type as Procedure. The procedure is a set of instructions that does not return a value. Press Enter. The homing routine is now created in the main module. A module is a set of data declarations followed by a set of routines. The modules can be saved, loaded, and copied as files. In general, these modules are divided into program and system modules. Click OK. Click Show Routine. Now, the newly created homing routine is displayed. A target is the coordinate at which the robot will reach. The home target position of the robot is added as an instruction in the homing routine. The target consists of the instructions for the position, orientation, and configuration of the robot. Next, you will learn how to add motion instructions in the homing routine. Click or press Next to continue. At the bottom left of the Flex Pendant window, click Add Instruction. The program consists of several instructions describing the work of the robot. There are specific instructions for the various commands, such as to move the robot, set an output, and so on. In the Common section, click Move ABSJ Instructions. Move ABSJ, also known as Absolute Joint Movements, is a robot motion instruction. As per this instruction, the robot moves from the current position to a new position in absolute joint values. Double-click the asterisk symbol in Move J asterisk to enter the target of the robot. The Data section appears. Click New to create a new joint target. Click OK. The current position of the robot is defined as Joint Target JPOS10. Click OK again. The targets and paths are used to program the motion of the robot. A path is a sequence of instructions used to move the robot along a sequence of targets. Now, you will learn how to add the motion instructions in the main routine and jog the robot to the target position. Click or press Next to continue. Click Routines. In the Routines section, click the main routine. The main routine usually starts when the Start button is pressed in auto mode. Click Show Routine. In the Common section, click the Move J instruction. Move J is used to move the robot quickly from one point to another when the movement need not be in a straight line. In the Add Instruction dialog box, click Below to add the instruction below the current selection. Double-click the asterisk symbol in Move J asterisk to enter the target of the robot. Click New to create a new target. The current position of the robot is defined as Robot Target P10. Click OK. Click OK again. Close the Flex Pendant window. Right-click and choose Orientation, and then Left. Zoom in by rotating the mouse wheel to view the left side of the robot. Select the robot base. Now, the coordinate system displays at the TCP of the robot, which can be used to move the robot from the current position to the target position. Select the Z-axis and drag the TCP to move the robot vertically down in a negative direction. In this case, move it to the 1236.48 mm position in the workstation. Select the X-axis and drag the TCP to move the robot horizontally backwards in a negative direction. In this case, move it to the 495.46 mm position in the workstation. Right-click and choose Orientation, and then Top. Zoom in by rotating the mouse wheel to view the topside view of the robot. Select the robot base. Select the Y-axis and drag the TCP to move the robot laterally in a positive direction. In this case, move it to the 472.97 mm position in the workstation. Select the X-axis and drag the TCP to move the robot horizontally backwards in a negative direction. In this case, move it to the 920.80 mm position in the workstation. Select the Y-axis and drag the TCP to adjust the robot position to the center of the plastic storage crate. In this case, move it to the 579.15 mm position in the workstation. On the Controller tab, in the Controller Tools group, click the arrow next to Inputs/Outputs to open the Virtual Flex Pendant window. In the Common section, select Move J. Now, the current position of the robot is added as a joint motion instruction in the program. P20 is the name of the target position number 2. Close the Virtual Flex Pendant window. Right-click and choose Orientation and then Left. Zoom in by rotating the mouse wheel to view the robot in the workstation. Select the robot base. Select the Z-axis and drag the TCP to move the robot vertically down until the vacuum gripper touches the top surface of the box. In this case, move it to the 1054.51 mm position in the workstation. On the Controller tab, in the Controller Tools group, click the arrow next to Inputs/Outputs to open the Virtual Flex Pendant window. Select the Move L instruction. Move L is an instruction that moves the robot linearly in a straight line from its current position to the specified position. Now, the current position of the robot is added as a linear motion instruction in the program. P30 is the name of the target position number 3. In the Common section, click or press Next. Click Wait Time. The robot can be programmed to wait for a specific amount of time or to wait until an arbitrary condition is satisfied. The Move instruction will work as a waiting instruction because the execution does not continue until the robot has reached its target position. Click 1, 2, 3 to enter a specific wait time. In the number pad, click 1 to set 1 second as the wait time. Click OK to confirm the input. Click OK to continue. In the Common section, click Previous to return to the previous instruction page. When the robot reaches the target position, the digital output signal is set to On, and this enables the robot to attach the box to its vacuum gripper. Now, you will learn how to set the digital output signal to the On state. Click or press Next to continue. Click Set to set the digital output signal process to 1. On the Data tab, click Output 1. The box attaches to the vacuum gripper when Set Output 1 instruction is executed. Click OK. Click or press Next. Click Wait Time Instructions. Click 1, 2, 3 to enter a specific wait time. Click 1 to set 1 second as a wait time. This will make your program wait for a second to execute the next line program command. Click OK to confirm the input. Click OK to continue. Click Previous to return to the previous instruction page. Now you will learn how to jog the robot from the target position of the box to the packaging box. Click or press Next to continue. Select Move L. Now the current position of the robot is added as a linear motion instruction in the program. Here P40 is the name of the target position number 4. Minimize the flex pendant window. Select the Z-axis and drag the TCP to move the robot vertically away from the plastic storage crate. In this case, move it to the 1340.95 mm position in the workstation. On the Controller tab, click the arrow next to Inputs Outputs to open the virtual flex pendant window. Click Move L. Now, the current position of the robot is added as a linear motion instruction in the program. Here, P50 is the name of the target position number 5. Minimize the flex pendant window. Right-click and choose Orientation and then Top. Zoom the top side view by rotating the mouse wheel to check the position of the robot. Select the robot base. Position the robot to reach the packaging box. First, move the robot laterally along the y-axis in a positive direction. Then, move the robot horizontally forward along the x-axis in a positive direction. Finally, adjust the robot position to the center of the packaging box. Open the virtual flex pendant window. Click Move J. The current position of the robot is added as a joint motion instruction in the program command. Here, P60 is the name of the target position number 6. Now, you will test the robot's target position that you have created. Click or press Next to continue. Click Enable. Note, in the manual mode, this button enables the device to turn on the motors. Click Debug. The debug option gives you access to move the program pointer to routine, main, cursor or PP. Click PP to main. Now, the program pointer will move to the beginning of the main routine. Move the flex pendant window to the left of the screen to view the program simulation. Click the play button to view the program simulation. You have successfully performed the initial steps for creating a robot program using the offline method.
If you found this video insightful and wanted to gain more practical knowledge, you can also check out our other skill videos of the Pick and Place series. If you have any doubts, click the Inquiry Now link below or visit our website www.cnctrain.com. Make a study plan and stick with it. Why not? Set steady reminders to subscribe to our channel to get our weekly learning videos on time. Continue learning to achieve your goal. Thank you.